So good afternoon, everybody. And I thought it would be good morning, but this change in timing has caught me also off guard. I'll try to keep my talk short. Um, I think I have slides. Maybe somebody can load my slides out there. So I'm a teacher by profession, so that means I get paid to talk. And if I get paid to talk, that means you're at my, your misery is my luxury. So I need to be warned by somebody that if I tend to extend the time, start flapping your arms and let me know that you got to stop. So one thing, I'm a professor for development biology and genetics, and my group has been interested in aging for a really long time. And that interest, which was fueled by specialists in our area of research, which is what we do. We love to look at molecules. We look at cells under the microscope. I was quite happy doing that for many decades. But the interest of a lot of my colleagues into looking at various aspects of aging research led to initiation of something what we now call as Longevity India Initiative. And if you actually translate the word Longevity India, it actually means Ayushman Bharat. So it actually ties in very nicely. That was not the intent which we started with, but it turned out to be the one which is what we're trying to do. I'll talk about what we're doing in the Longevity Initiative close to the end of my few slides, but I'll briefly tell you about why we need to study longevity and health span in the current context as it stands. All of you are here. I presume all of you are interested in health, and all of you are also interested in health lifespan and longevity. So I presume these three things are used quite interchangeably, and I'm going to tell you about why they may or may not be the same thing. The slides are not changing for me. All right, so these digital devices, we do not know where to point them at, right? Okay, so when we talk about health span and we talk about lifespan, one of the things which actually strikes to us is that all of us are talking about improving quality of life, right? And when you look at dictionary, and you pick up any dictionary and you look at the word longevity, it does not anyway says in that dictionary meaning it's about long life. It actually talks about durability. And that durability could be for anything living or non-living. It doesn't matter. So when you talk about longevity, basically, if you're a vehicle or you're a car or you're an individual, we talk about how durable can you be. And for durability, we need to understand that what needs to be fixed. I wish we had a manual for human body like we have for a car, where it says every 10,000 kilometers, go had an oil change done. And every 5,000 kilometers, turn the wheels around and get an equilibrium balance checked. And we realize our balance when we have actually lost it. So that's a problem with our life. So historically, when we talk about longevity, the word says it here, longevity is linked to greed. Wish to live long is always been conceived as being greedy. And health span is always linked to need. Somebody very nicely mentioned in the morning, for a common person, health span is more critical. For a person who's got a lot of riches at their disposal, it's a lifespan we are looking at. So I think we need to bring both these words into one consolidated point, which is how do we improve quality of life. It doesn't matter whether you have the money or not. Ultimately, that's what we would like to champion. Can we study and make good decisions about our health? So when we do that, we have to also talk about ethical, social, and also something which is very critical, equity. Equity is something which everybody has an equal stake in the game. Whether you're a rural context or an urban context, it's a value for everybody to be healthy. And for that, what we need is collaboration. Collaborations from everybody who's here, everybody who's not here also. A person who's living has actually invested into longevity and long life, because you may or may not get any disease, which is what our healthcare system is banked on, treating diabetes or treating pathologies. Well, aging is not something which you have a choice about. It's not even luck. It's that if you're alive, you're going to face longevity issues or aging issues. So we are all invested into this problem. And last point which I want to mention, lifespan is not equal to life expectancy. Life expectancy is something how long you can live in a given condition of your body. Lifespan is for a species, for human beings, it's capped at 120. And lastly is health span. Health span is how long you stay healthy without compromising your physical function. For all of us, human beings, the biggest problem is mobility. Can I stay mobile in late ages of my life? So this is a problem, and how do we address that is going to be a problem. All right, can somebody again? I think I skipped a bunch of slides here. All right. My God, this looks like it skipped a whole lot of slides. Can somebody change slides for me when I say change the slide? So let's go to slide number 2, right. So let's look at life expectancy gains, which means what are the things which actually allowed us to live longer? And actually, historically speaking, it's basically the public health changes which has allowed us to live longer. Forget about medical treatment, which added to 20%, pharmaceutical or drugs added 30%, but it's actually public health initiatives which started in early 20th century, which has allowed us to really live long in terms of our health span. Next slide, please. And if you look at what are the discoveries from human perspective, historical discoveries, which actually changed the way we look at health. And this is the list which I think all of us should know because I presume all of us have passed high school, so this is the information which is taught to us in high school. Agriculture, sanitation system, vaccination, the first proactive healthcare regime, vaccination, antibiotics, first reactive therapeutic design where we kill some foreign life forms, clean water, hygiene systems, medical imaging and diagnostics, improving our ability to see things better, anesthesia, managing pain. If you think carefully, we don't think about pain till it hits us, but managing pain is a very big thing. And anesthesia is one major discovery which actually allowed us. And then public health policies and digital health. We heard some of the speakers talk about, 4 Ps, preventive, participatory, personalized, and also predictive healthcare. This is where the healthcare system is going. And I'll talk to that a little bit about that later, that these 4 Ps are not easy to realize because there are a lot of problems in making these 4 P realizable. Can I go to the next slide, please? Let's look at from these features. All right, let's look at the features which changed our health span perspective. How healthy can we live? And you see that a lot of things are actually repeating from the previous list here, which affected health. But what affected our health span? Antibiotics, vaccination. But now let's look at the list of things. These are the things which actually allowed us to cure diseases. Insulin for diabetes, cardiovascular therapies, organ transplantation, cancer treatment, medical imaging, and hormone replacement therapy. These things actually affected our health span quite nicely. I deliberately skipped one in this list, which is called caloric restriction. Now, interestingly, coming from pure sciences, we all of us love to look at things and molecules which allow us to improve length of life, lifespan. People have done a lot of experiments, and numerous experiments in using genes, drugs, so on and so forth. And we have done it from mouse, worms, whichever model system we like to work with. And trust me, we have not found anything which works better than caloric restriction. So that is actually a big bummer. Then, we have invested so much, still caloric restriction runs with the milestone about long life. Let's look at features which affect our health span. And it's very important to understand these features because we're sitting in India, but we are following what the West told us, that this is what we should do. For us, there's a lot of things that are very different. Genetic influences, our genomes, our genes are what we are born with, and most human beings share pretty much all the genes. There's no major difference. But let me tell you one thing. Our genes actually talk to the environment, and we call it epigenome. An epigenome is something which is influenced by the environment heavily, which is what our exposome is. Exposome is our lifestyle, our environment, our pollutants, and we live in a tropical country. That means bacteria, fungi, pathogens live with us throughout the year. We do not have this beautiful freeze-thaw cycle. We have much, much larger burden on our immune system to manage this pathogen. And there's some people in the audience here who actually work on immune system, and they can vouch for that. Our immune system is actually always working in a hyperactivated state, much more than what works for the Western counterparts. So what are the risk factors? And risk factor does not need introduction to this audience, and everybody knows these are the known risk factors which affect lifespan. But let's look at what is the features in India which makes it different. Intrinsically, our genes are same, but our epigenetic differences are quite different. One small study, I think there is some people in this group also from a company who've done epigenetic analysis. We have done similar epigenetic analysis. And what we found in Indian population, the changes which occur in our genes, which genes get turned on and turned off, is actually different from the West. And if you go by that, that means any Western yardstick of your health may not apply to us. One of the greatest drugs which people talk in West is extend lifespan is rapamycin. Rapamycin knocks out your immune system. Please come take rapamycin in India. You will definitely not get old. Guaranteed, because you will die young. So it works very well because that's a rule. Did you knock out your immune system? You're not going to live in India. You need your immune system in India to live happily. Then you have extrinsic factor. An extrinsic factor is our healthcare, our environment. And we cannot ignore that when we talk about healthcare, there's aspect of ease and cost of access, issues about quality of healthcare, penetrance of care, and where does it need to reach in the rural setting? Do we need all the sick people to really come to hospitals? How much of the healthcare burden can we shift to primary healthcare facilities? But that would mean a different viewpoint on managing health. And lastly is the interface of intrinsic and extrinsic factor, how our genes are talking to the environment. And that is basically driven by our lifestyle, our diet, early diagnosis of a disease, personalized care, and diversity is the main fundamental challenge in this type of interface. There's somebody who said, we are what we eat. Very famous, but there's another guy who actually said, and I completely agree with, he said, we eat what we are, which is indeed true. If you are born in South India, your comfort food is what you want to have in your breakfast every day, no matter which part of the planet you throw at. So Indians who go abroad, they still eat our aloo parathas. They still eat our idli dosa. So we eat what we are. That means our way we talk to environment and our gut is very personal to us. There's some science insights in aging. Please tell me when I'm running over time. As I said, I tend to do it very frequently. And in science design, people have asked question, what prevents us from living indefinitely, preventing us from living very long? They're very interesting answers. This is kind of a debate which we can talk days about it. But simple rule is these following points. Aging is not selected. We have all studied Darwin's rule of selection of the fittest, survival of the fittest. Don't worry, I will not fall. I mean, I tend to live long. So the idea is, if you are already reproducing before you get old, you've already passed your good or bad genes or whatever genes you are to your next generation. And if you have done that, evolution doesn't care whether you live to 150, 130, or 80. You've already reproduced. That means aging and longevity is actually not a design of evolution. Evolution does not care. Evolution only cares about survival and retention of the genes. Aging also considers as a system which prevents us from getting cancer. The longer you live, the more you breathe oxygen, which is the point number 3, the more your body undergoes mutations. You get exposed to environment, more mutagenic environment, more chance of getting cancer. How do you prevent cancer? Nature's independent mechanism is become old, don't get cancer. So now the choice is whether you want to live long and get cancer, or you do not want to live long and not get cancer. Then we have something which is called exhaustion of immune system. We constantly get bombarded with pathogens. They're always challenging our body. And this immune system gets exhausted. And this exhausted immune system is what is causing us to get old. Because the system is shutting down, and inflammation slowly creeps in your body. Because your immune system is weak, you need a carpet bombing mechanism, which is inflammation, to protect you from pathogens. And that inflammation is what is killing us. And we saw that in COVID, the inflammation is what actually killed us rather than the pathogen per se. Then lastly, we eat food. We need food to survive. That means every time we eat, we are actually exposing our gut to some foreign pathogens. Bacteria, fungi, virus, and so on and so forth. Slowly, our gut erodes, and what we have end up getting is a leaky gut, which causes aging. So, and lastly, we have something called as zombie cells, the senescence in our body, which we love to study, and these zombie cells is what causes aging. Now, science has fallen short on a lot of parameters of aging. Aging is far more complex. It's not few molecules, few drugs are not going to make a difference. We're not going to dent even the surface of aging because it's far too complex. Model systems don't work. We are not mouse, we are not flies, we are not worms, we are human. That means a lot of learning from this model system, which fundamental biology has given to the world, do not really work linearly to the human system. There's too much of individual variability. In India, where every 80-kilometer diet changes and language changes, we are looking at humongous differences in terms of features of aging across this country like India. In US, top to bottom, you pretty much stay the same. But in this country, that diversity is actually more than a continent. So we are dealing with a different beast altogether when we start to study India. And also psychosocial features, impact on mental health, impact on social environment. It's actually something which is not really explored very well. Let's talk about what we know about medicine. This is historical slide. Medicine, 1 point we observe and wait. Somebody got sick, we saw. 2 was reactive, test and treat. 3 is what we are, test and prevent. And the future is 4.2, monitor and optimize. The idea is very simple. We want to look at what makes you sick, what is not working out for your body. We want to monitor it. We have heard all entrepreneurs want to start innovation into monitor, a device which will tell you what's going wrong in your body. Big question, monitor what? Monitor the features which is giving you indicators of sickness or indicators of your health. Where are my health parameters? My blood report does not tell me I'm healthy. My blood report tells me whether I'm sick or not. That's a fundamental flaw in that philosophy. That I'm looking at my blood report, I'm turning pages to see if something is bold, red, or underlined. The rest, everything doesn't matter because it's in the normal window, chalta hai. And then when something pops up red, we start taking preventive measures. But the problem is when you're talking about health, we cannot look at that report. We need new features, new markers. And that's where we need to look at new science. And new science is about how do we look at you? How do we understand you at a molecular level? We do genome analysis, we do genome profiling, looking at your gene, looking at what genes are wrong, what is your disease risk profile, tell you about what you should and should not be eating, you should be sleeping, and so on and so forth. But that's not the end of it. Your gene talk to your environment. We need to look at markers. Markers of you as you are today, not what you're born with. And what you're today is your metabolic profile. The features of your body, your proteome, your metabolome, your lipids, your sugars in your body, they're all talking to each other. And that's what we need to identify. We need to identify features of you today so that I can do something and prevent something from happening tomorrow. And lastly, using this information, what you're born with, what you stand today, I need to come up with therapies, tailored therapies, personalized, hyper-personalized preventive therapeutics. And how far are we? We are quite far. There are few companies. There's one company stall outside Biopeak. There's one other company which are working on this domain. We're trying to figure out these features to give tailored therapies to address what you're doing. But there are not too many initiatives which are going on. So this is where we need to invest heavily. We need to invest in trying to understand your features of your body today. Multi-omics. Genomics is one of the omes. And there are other omes. There are proteome, lipidome, glycome, epigenome, immunome, and we need to understand that. And that's where the data need to be collected. These omes will give us features, novel biomarkers to understand your health, and which could be used for validation and translation for therapeutics. And that's where we come in. We started Longevity India to create this omics information for India. We need to understand Indian as we stand today. We cannot bank on Western health data to take clinical decisions for Indian. We need Bharat data. And that's what our study is called, Bharat study. It's an acronym, biomarkers for healthy aging, resilience, what are features which make you recover from an adverse event, and what changes in your body when you undergo transition. For women, transition is a part of life. For men, it's not so much. Premenopause, perimenopause, postmenopause, what changes in the body? We don't even know that. We assume that some features change and we accept that. But along with that, there comes a multitude of medical complexities we need to understand. So this study is a very big study in which we're trying to collect plus 2 million data points from healthy Indians. Healthy Indians are not in hospitals. They are at the rural setting. They are in a population. Healthy person does not walk into hospital. If they don't walk into hospital, how do I study them? So that's where our team goes out at a population level, collects data, collects samples from healthy people to build a database for India, which we call as the Bharat baseline data. The main system which we're banking on Longevity India is Ayushman Bharat. We are science people. Science is one pillar of this puzzle of aging, longevity, or health span. We need clinicians, they are partners. We have a lot of clinical hospitals which are partners in this study. We need technology. We need companies which give access to state-of-the-art technologies. We have companies who are working with us from day one. Tata 1mg is giving us their complete diagnostic workflow. Bruker Daltonics, gut aging studies. A lot of companies which work with us to give us access to technology. And lastly, if you're discovering something, if you want to change the landscape, we might want to engage with society. So we have policymaker initiatives like AHPI. They're partners in this. We have Dementia Research Alliance. We have Vaya Vikas. We work with them so that whatever we discover can be implemented on the ground. Next project which we're dealing with is called copycats. We are scientists, but I cannot do experiment on you. Nobody will give me a part of their liver. And I want to say I want to study aging liver. How do I do that? I want to study aging lung. In Delhi, pollution and politician, two things live. How do I understand what does it do to your lung? Pollution I can certainly study, but who will give me healthy lung? So what we do is we make model systems of lungs, liver, skin in our labs, and we age them by exposing them to the environmental radiation, pollutants, chemicals, and see what changes in them when they undergo aging in lab. And using this system, we are looking at effect of therapeutics. How many of you know how many drugs Amazon sell for anti-aging? Do you have any idea? 2,000, 3,000, 4,000? Actually, you put a search, you will get millions of molecules and companies. Do they work? We don't even know. We actually did a very interesting study. We took the top 20 molecules, dumped them on our model systems of aging and asked, well, they can at least suppress inflammation. Forget about anything else. And guess what? Except a couple, none of them actually work. No matter how much dose you give it. Some of them are actually outrightly toxic. Some of them are so toxic that even the non-aged cells die. Do you want to consume them? We have no idea. But they are being sold. We trust our liver, and we work with that. And next is something which is very India, we call it Nanik University, it's traditional knowledge. A lot of very Indian knowledge is very much there in family setting, it is sitting there. We know what we need to do. So we're trying to validate traditional knowledge using molecular tools, and we want to bring a database so that we can use this traditional knowledge to bring it mainstream, bring evidence, molecular evidence that they work, and bring it to you. And lastly, something which is an outreach program. We do a lot of podcasts, campus ambassadors, run newsletters, webinars, and people can get a lot of information. So this is the long-term longevity India proposition. This is what we do. The blue and the pink and the green is what we hope to have. Reduced hospitalization, dignity in aging, preventive health, improved quality of life, and social engagement. And our first win, I think, would be to establish India baseline. We call it the Bharat baseline. Give value for India, which is gender corrected, your diet corrected, your geographical location corrected, based on which a clinician can make decision about whether your features of blood work is abnormal or not. We would like to give that power based on collecting data from healthy people. New baseline for India, which is non-Western oriented. So this is the looking forward part of longevity. Let's take a couple of minutes. We're looking at innovation, global collaboration, focus on prevention, and social adaptation of what we're trying to do. So it's a project which runs across multiple features. And the key takeaways is while science is illuminating it, emerging technologies are needed, but also we must consider ethical, social, and equity considerations, and definitely we need collaboration. Companies, industry, startups, everybody must join hand in an initiative, which is what we're running, but also there are a lot of initiatives running in silos. We must work together to actually address India-specific concerns. So this is a QR code. If you want to support us in any way, participate as sampling center, support for women's studies, advanced equipment acquisition. This is a QR code which we can share with you for supporting us. And if you're interested in joining the Bharat study, provided you're healthy, fit, and no comorbidity exists in your body, you please join us. And scan the QR code. We'll tell you where you can come and join for sampling. And we will be more than happy to actually make you an active participant in the Bharat study. And I'll stop here, and thank you very much.